Blockchain tops the list of most in-demand tech skills for 2020. Blockchain developer ranks number one in emerging jobs in India. Blockchain has become a line of business for various organizations. Gartner recognized blockchain as one of the disruptive technology worth watching in coming days. But technologists still find blockchain very difficult to understand, and today I'm going to help you with it. Hello, everyone, and welcome to this introductory course by Study 9 on blockchain. This is Naman Kabra, and I have been into blockchain industry since past 3 years. I've been working upon various research topics in this disruptive technologies. So today we'll be talking about five major aspects. To begin with, we'll be discussing about Bitcoin, what it is, how it works, what is the history so far about Bitcoin. Next, we'll go and see what blockchain is all about. We'll go on defining blockchain and also understand what are the terminologies involved in it. Then we'll discuss what are the various types of blockchain and how to differentiate amongst it. Followed by, we'll move on to a major breakthrough in this technology, which is Ethereum blockchain. And lastly, we'll be talking about use cases and why these use cases are disrupting each and every sector of the industries. So let's begin. Firstly, I want to clear out this misunderstanding which almost every newbies in blockchain feels is that blockchain is equal to Bitcoin. But let me clear it out. Blockchain is neither read as Bitcoin or written as Bitcoin. Bitcoin is completely different from what blockchain can actually do. Bitcoin was the first cryptocurrency created using blockchain technology. We'll be talking about it in detail in coming slides. It was the first application built which introduced blockchain technology to the world. And now it is used as a virtual currency or digital cash for payments. On the other hand, blockchain is the technology on which Bitcoin is built. It is believed to be Internet 2.0 and expected to rise to 40 billion US dollar valuation in 2025. And blockchain is the focus of this introductory course. But let's see what Bitcoin is all about and how it all started. So, in 2008, Satoshi Nakamoto, an alias, introduced Bitcoin in terms of white paper. In 2009, the first public blockchain network was launched in the form of Bitcoin, which then led to a completely revolutionized concept named as cryptocurrencies. In 2010, first crypto stock exchange launched for Bitcoin. And the very first transaction, funnily, was to buy two pizzas for 10,000 Bitcoins. The reason why I'm emphasizing on this huge number, you'll get to know very soon. In 2011, one Bitcoin was equal to 1 USD, and Bitcoin was in action now. And more investors started getting into crypto space, and Slashdot mentioned BTC and introduced it to a very larger crowd across the globe. In 2013, the value of Bitcoin rose to 100 times to what it was in 2011. And Gartner recognized Bitcoin as one of the trending topic. This was the initial phase where there was necessity to differentiate between what are the myths and the real facts and what are the current trends and what vision each of this technology follows. In 2014, a lot of industry experts started getting into this journey and heavily research based labs were built in various top tech giants in the field of blockchain, or also called as DLT, distributed ledger technology. In 2017, the value of one Bitcoin crossed 10,000 USD. Now imagine buying two pizzas for 10,000 Bitcoin. That just squares up in US dollars. And investment in blockchain based enterprise use cases grow exponentially. Companies such as IBM, Amazon, Goldman Sachs, HSBC, various banks in UAE, Facebook, each and everyone started investing in blockchain. And in 2020, blockchain as a service was a common service provided by cloud giants. And this is the year of launch of Ethereum 2.0. Projects such as Hyperledger, which is one of the most popular protocol used in blockchain by enterprises. DeFi, which is nothing but the decentralized finance applications on top of Ethereum based blockchain started evolving. So, what is Bitcoin? Bitcoin is a cryptocurrency created by an alias named Satoshi Nakamoto. Cryptocurrency? It is nothing but a digital currency built with strong cryptographic protocols that make financial transactions much more secure, confidential, and verify the transfer of assets. The market capitalization of Bitcoin currently is above 140 billion US dollars. So why Bitcoin is different from the traditional form of currency? Firstly, it is completely decentralized. There is no central entity like banks which we have to rely upon to perform the financial transactions. It is a completely peer-to-peer electronic cash system. Peer-to-peer we'll be discussing when we define blockchain. So the current nature of money, what could possibly go wrong is, imagine a credit card, a debit card, your banks, your gold commodity. What could possibly go wrong? Well, the assets can be frozen. These assets can be seized. There is always a hidden fees which you are unaware of applied to your transactions. There can be various possibilities of robbery, hacking, financial theft, privacy breach, which plays an important role in today in terms of data. So what is the question? Well, the question is, can you completely trust the current banking system? If I have to divide our current banking system into four pillars, it would be the services it offers, the way it manages the identity, the way it manages the record, and what is the trusting mechanism. So current banking system offers services to transfer and record money, identity management for storage for your personal information and account balances, to track account history, particularly for our audits, is nothing but the record management, and trust, that is completely governed by a government regulated body. So what Bitcoin offers? Well, every blockchain based system and Bitcoin as well offers a trustless trust, meaning you don't need to trust the other party, but the technology or the network would make sure you are in the trusted environment. There is always a consensus mechanism which every peer involved in the network needs to follow. The identity management makes sure that the parties involved in the networks are completely anonymous, maintaining confidentiality and privacy of the data. Entire network is distributed ledger-based technology. Each transaction is maintained across the network, which makes it easy to track and offer the completely transparent auditable system. Talking now, when we talk about the current bank, I want you to think of a situation. Let's say You are buying a water bottle from party B and you are nothing but the party A. Now, being a buyer, there is going to be a transaction between you and the seller through a mediator such as bank. Now, imagine there is some incident at bank, and now, due to this incident, all the parties involved in the networks are affected. You have to rely on banks to bring back to normal for the transactions to perform. This makes it very inefficient, expensive to maintain and service the data, and vulnerable to potential threat in terms of hacking and frauds. So, what are the problems here? Well, we can see that there are bank frauds involved. It is less secured. There is no privacy involved. The data can be exposed to third parties, and you never know where your data is going. And it becomes very expensive to handle this centralized system. This is the biggest drawback of the current financial systems. How blockchain solves it and what is the solution for this problem? Let's see. So, the solution is a completely decentralized, distributed, and a permission network. Now, imagine you are into a distributed ledger system wherein each and every transactions in the network is appended on the ledger. So, what a ledger is? Ledger is nothing but the set of events of transactions happening in the network. Consider it as a general ledger book which you follow to write something related to finance. And once this is happening, it becomes very easily to achieve the provenance in the network, and it makes sure that the network is append only. That ensures that you have an immutable blockchain based network. Now, what are the benefits of such system? Lesser frauds, definitely, because you don't have to rely on centralized body since the network is completely decentralized. Secured, obviously. Privacy enhancement. Each and every transactions involved in the networks are identified through a transaction hash, and the parties involved in the networks are completely anonymous. This ensures that privacy is enhanced. There is an access control mechanism defined in the consensus mechanisms to make sure that your data is safe with you and you have that right to give your data to any other party. It's completely immutable system and a reliable system to trust for. This is what blockchain is all about. So now moving to define blockchain. If you see this GIF carefully, half of the definition of blockchain is solved here. When you see the transaction happening between A and B, you see that a transaction is been recorded on the ledger. And once it's recorded, it's been appended throughout the network. So let's define blockchain. Blockchain is a peer-to-peer distributed ledger that is cryptographically secure, append-only, and immutable, and updated by consensus among peer nodes. I know it's too tough to digest these heavy terms, so let me split it. Firstly, peer-to-peer. What we mean by peer-to-peer is, imagine a system such as torrent wherein you don't rely on central party to get or fetch some data. When you are downloading some movies or data from torrent, it is an example of peer-to-peer system. Blockchain is also a peer-to-peer system. Distributed ledger. Now, it is very important to understand what distributed ledger is. As you have seen in the GIF, once a transaction is happening between A and B, the transaction is firstly recorded on their ledger and then notified throughout the network. This makes sure that network is always up and running. And even though, let's say, a third party C in the network is down, due to some failures, the distributed ledger mechanism would make sure that the network will be up and running. Cryptographically secure. When we talk about cryptography, it makes sure that the network is completely secured. Cryptography involves various terms such as hashing, secured hash algorithms, SHA-256, SHA-512, SHA-3. We'll be talking about these cryptography and hashing algorithms when we discuss more in the course. It is an append only. When we say append only, the data what goes into blockchain cannot be edited, and it is an immutable consensus, meaning immutability is maintained because of its property of append-only database. And consensus mechanisms ensures that what are the parties involved in the network and what are the regulations they need to follow to be in the network and perform transactions. I hope I clear you some of the points here. We'll be discussing more in the coming courses, but today it is very important for you to understand these 5 points. Number one, peer to peer. Second is distributed ledger. Then comes cryptographically secure. Fourth one is append only and immutable. And last one is consensus mechanisms. Moving on. What are the types of blockchain? I have divided here on the basis of two factors. Number one, which you see horizontally, is the accessibility. Blockchain can be differentiated in two types on basis of accessibility: permissioned and permissionless. And on vertical axis, you see is visibility. Visibility is nothing but the way the blockchain network is visible to the peers, and it can be divided into two: public and private. In accessibility, there is also one more new type of blockchain which has come into picture, is consortium or federated blockchain system. We'll be talking about the third type in the coming courses, but today we'll be differentiating on basis of these two factors. So what is a public and permission blockchain? In this type of blockchain network, operators receive special access rights. Right, the right operation is given to all parties involved in the network, and read is restricted. When we say permission network, whosoever involved in the network has the right to read the data is restricted. This ensures the privacy in the networks, and this is what makes it very specifically useful in banks and decentralized finance applications. Our next category is public and permissionless blockchain. In this type, the network is completely public with read and write access to anyone. It is not used in enterprises due to the read and write access given to everyone, and it is widely used to target the public community. This is the type of network used by various cryptocurrencies or altcoins, which we call, such as Bitcoin, Ethereum, Litecoin, cryptos, other cryptos such as Ripple, Stellar, and so on. The third type is private and permissioned. Private, private meaning the transactions and the network is restricted to some people. Permissioned means that the net read operation is restricted. So the focus of this type of networks is useful when we need a business driven large infrastructure, and it is majorly used by enterprises. Some of the examples are R3, Corda, Quorum, and importantly, Hyperledger, which is one of the leading private permission network used by enterprises to solve the real world problem. The last quadrant which you see is private and permissionless. Such type of network never exists because Once we say that network is private, we need to ensure that there is some permissioning mechanisms. If the network is going to be permissionless, it is nothing but a public network. Moving on are the various use cases of blockchain. Today, we'll be talking about various use cases across the domain, and this graph shows the diversification of where and when blockchain is used. It can be used in supply chain and traceability. IBM, one of the leading giants in blockchain, is using it. Digital identity, well, yes, the decentralized digital identity is one of the most trending or hot topic in enterprises. Companies such as YOLOCOM, Showcard are some of the products built on top of blockchain for digital identity. Blockchain IoT plays important role for trusted data sharing and computation. One of the product by Posh, that is TrueFoot Plus, is a very popular use case. Other examples include peer-to-peer energy trading platforms used by Singapore government, or ePlug, which is also one of the use cases of blockchain in IoT. Talking about medical and healthcare industries, there are enormous use case to ensure that the patient's record is privacy enhanced and the data what patients share is kept to them. They have the right to share their data with the right person. And some of the examples are MediLedger, PharmaTrace, B3I, which is one of the reinsurance governing body, which is making sure that insurance claim settlements happens on top of this decentralized networks. When we talk about banking and financial institutions, which is my favorite, the reason being I have a research paper in it named Mudra Chain. Go have a look on it, because that is something wherein I proposed a novel two-factor mechanisms to enhance the current check settlements and cross-border settlements in banking and financial institutions. HSBC is also using blockchain for letter of credit platforms. When we talk about digital content, document storage, validation of this digital data in current world plays an important role. With the introduction of technologies such as IPFS, which is nothing but interplanetary file storage, again a peer-to-peer file system. This integrated with blockchain created various products such as Filecoin, BlockCDN, which are used in education industries to verify the certificates, to verify the degrees, to verify the identity of a particular employee or student, and ensure that their data is being stored peer to peer. Remember, as I said, what goes in blockchain would always stay in blockchain. And the three pillars of blockchain are confidentiality, security, and privacy. This is my favorite quote, and I use it generally. What goes in blockchain stays in blockchain. Moving on to one of the major breakthrough in blockchain is Ethereum. Ethereum is a Turing complete protocol that uses its coin, which is Ether, as fuel to perform transactions. Turing complete, well, we are not getting into it. The primary purpose of Ethereum is to have a platform for decentralized applications on top of smart contracts. But what are smart contracts? Smart contracts are nothing but a program, or you call it a code, that contains the business logic or the entire logic of how you want your network to run. And we, in the coming course, will be writing our own smart contracts and making our own blockchain. You'll be making your own token, which can be on your name. Moving on, how Ethereum was introduced in the world. As I said, in 2008, after the launch of Bitcoin, other cryptocurrency experts started exploring it. And in the 2012, Ethereum was introduced by a 19-year-old guy, Vitalik Buterin. In 2013, the white paper of Ethereum was released, and in 2014, Ethereum project was officially announced, and pre-sales of 60 million Ether tokens was given. In 2025, Ethereum was launched as an open source project, and this was the year when people realized the potential of using blockchain in enterprises. In 2016, there was one attack on public blockchain, Ethereum, which led it to split into two categories, Ethereum and Ethereum Classic. In 2017, various industry adoptions on top of Ethereum started and various protocols were built, such as Quorum, Layer 2 protocols, which targets the scalability aspect of blockchain, which we'll be discussing in more detail in the coming course. And currently in 2020, Ethereum is going to launch Ethereum 2.0, which is going to be one of the most disruptive technology on top of blockchain. It would introduce you to the new world of staking mechanism on, and the applications built using Ethereum would then be called as decentralized finance applications or DApps, and it would ensure that real world assets are bought to digital assets. So, what smart contract is, and these are the major four components of Ethereum.